Would 100 be it?
Okay, how did you get 100?
0 to 9 means there's 10 numbers or digits. So you multiply. Since there's two spaces, you'll do 10 times 10.
Yeah, very
That's
good, because you have 10 possibilities here, 0 to 9. And then for each of these 10 options, there are again 10 options over here. So you could have 0 in the third option. And if you have 0, you could get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10. Then for 1, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. And that gives you 10 times 10. Nice. Good stuff. So yeah, there are 100 possible codes. Okay. The next one says the fourth digit is larger than the third digit. How many possible codes are there? So it's the question down here.
Could it be 10 times 9?
Say that again, sorry.
10 times 9.
Okay, why?
Um, so it says there's 10 digits for the third. Wait, there's 10 numbers for the third digit. And for the fourth one, that would be 9 because it's larger.
Possibly. Okay, so wait, say that one more time.
Oh, was it the third digit? That'll be 10 because it's just all of the numbers. But the fourth digit, since it's larger than the third one, let's say it's 0, there'll be 9 numbers left.
Okay. What about if in the third position we put the number 8? How many would there
Oh,
be?
1.
Okay. So unfortunately, we can't just say that for, well, maybe it's true, but unfortunately, we can't just rationalize that for each number that we have in the third position, we then have 9 in the fourth position. Because already we can see that depending on the number that we put in the third position, that will then determine how many options we have in the fourth.
I'm not sure what to do then.
Let's approach it a slow way. Let's I mean, if we go through it in a way that's slower, however systematic, then that could help. So what could we do if we had to do it the slow way?
I'm not sure.
Well, give me an example of a number that can go in the third option, in the third column, in the third digit.
Like any number. I mean,
Yeah.
in between 5.
Okay, so if you were to pick 5, how many options do you then have for the fourth digit?
4.
And which digits are those, just to be sure that you have them?
Oh, 6, 7, 8, 9.
So read the statement again that's been well, that either underlined in red, slash the bit that comes just before part B. Never mind, actually, never mind. It should be me that reads it again. So yeah, the fourth digit has to be larger than the third digit. So yes, if 5 is in the third place, you then have 6, 7, 8, 9. So why can't we do that with every single um digit? We might start to notice something. Is that making
Um,
sense or not really?
Wait, can you repeat it?
So you've got the first position, second position, third position, fourth position. So we've got the third position, as in the third digit. So if, let's just say 0, the first digit, how many different numbers can go in the next one?
9.
Okay, so we've got 9 digits. And then if 1 were to go in the second, in the first, third digit, how many can then go in the second, in the fourth one? Sorry.
8.
Okay. Do you see what we're doing here?
Oh yeah. Wait, would you just add what's it? All the numbers between 0 to 9 up.
Um, it's one way of doing it. Yeah. Yeah, basically.
45.
Perfect. Yep. So let's just go through explicitly why is that. So we then see that with 2, you then only have 7 options. Yep, 3, 4, 5, 6, 7, 8, 9. 3, you only have 6 options. 4, you only have 5 options, and so on. When you get to 8, you only have 1 option. And then, of course, you can't put 9, because if you were to put 9, then there are 0 options if the next digit has to be strictly greater. So there we go. So yeah, we get 1 plus 2 plus 3 plus all the way up to 9, and that's 45. Another way it could have been done, actually, I'm just thinking about it, is looking at this first option. There were 100 just for all the possible codes. And then if you think about a 2-digit number, you're going to get 3 cases. Either the first digit, so if we've got 2 digits that we can put in, just another explanation, you can either get that the first digit is bigger, and obviously the second digit is smaller, or you can get that the first digit, sorry, is smaller, second digit is bigger, or you can get that they're the same digit. And then if we consider, so bigger, smaller, smaller, bigger, same, same, they're all the possible combinations, right, for the 2-digit numbers that you can have. Does that make sense?
Yeah.
So the ones that we want are the ones where we get smaller, bigger, because it says the 4th digit has to be larger than the 3rd digit. So we just need to get rid of same, same, and bigger, smaller. Well, if we get rid of same, same, there aren't that many. That's going to be 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, which is 10 different possibilities. And then with the remaining ones, with the remaining 90, well, you've got as many 2-digit numbers that start with a bigger number than a smaller number as there are compared to smaller to bigger. So we can just halve this, and that equals 45, leaving us with 45 is what we want. Just another way that I thought of. It's not something that you have to do. It's not necessarily the best way to do it. It was just another thought, and I thought I'd share it.
Okay.
Cool. Here's the next question.
Would it be 60?
Let's investigate. So you can pick a 5-digit even number. The first digit is odd, the second digit is prime, the 4th digit is a multiple of 3. How many 3-digit numbers could he pick? Okay, so 1, 2, 3, 4, 5. So we've been told constraints about the first. Well, we've been told things about different numbers. So with the first digit, are there how many possible numbers can we put?
5
Yep.
or
So
1.
what's that? Sorry.
Well, I was gonna say the numbers.
Oh yeah, 1, 3, 5, 7, 9. Yeah,
Yeah.
that's good. The second digit,
4.
very good because it's 2, 3, 5, or 7. And then what about the third digit?
3.
For the third digit,
Oh, wait, we don't know that one.
well, if they've not said
Wait, I
anything,
mean 10.
yeah, it's going to be 10. And then the fourth one, I think you mentioned it earlier.
Oh, yeah, 3.
Talking about that one. Yep, 3. What about the fifth one?
Would it be 10 as well?
We've got to be so careful. This one is actually restricted. Read the first line again.
Oh, 4.
What's that, sorry?
4.
Why 4?
Because there's 4 even numbers in between 0 and 9.
Are there? What are the 4 that you picked out?
2, 4, 6, 8,
There's one more.
0.
Yeah, 0. Because, for
Oh,
example, if you take the number 10, is that even or is that not even?
oh, it's even.
Yeah, and it ends in a 0.
Okay.
So we've got 5 there. And we are just multiplying those things together. So 5, 4, 10, 3, 5. And we just have to multiply those out.
3,000.
Mm-hmm. Okay, so I think they've miswritten this number, how many 3-digit numbers, because it's supposed to be 5-digit.
Oh,
Uh,
okay.
yeah, because I think they said 3 digits because they've described explicitly 3 of the things, but then they've also implicitly defined one of the digits by saying that it's got to be an even number. So yeah, it should have meant 5-digit number.
Oh, okay.
Cool. Here is the next question.
Um, could you just do 5 times 4 times 3 times 2 times 1?
Say that again, sorry.
5 times 4 times 3 times 2 times 1.
And how are you getting that?
Because there's 5 number cards. He said how many 5-digit numbers he can he wait, how can he arrange them 5 cards to make 5-digit numbers?
Mhm. Yeah, so okay. One way to think about it, and you are exactly right, is how many how many different numbers could go in the first option? Like for the first digit.
5,
Yep. And then how many remain for the next one?
4,
Yep. And then for each of those, how many remain for the next?
3,
Yep. And then for each of those,
2,
and then for
and
each of
1.
those as well. Yeah. So and that equals 120. Just as a side note, there is a shorthand way of writing this, and that's like this: 5 factorial with an exclamation mark. It means 5 times 4 times 3 times 2 times 1.
Okay.
Yeah, our final answer is 120. And just as another side note, this is the answer. But if you had something that resulted in 6 factorial, that would mean 6 times 5 times 4 times 3 times 2 times 1. And any other number, whole number, greater than 0, factorial is going to be everything multiplied down to 1.
Um,
Yeah.
in an exam, yeah, would
Mhm.
they give it to you? I think there's a calculator button like that. So would it be in a calculator or non-calculator test?
Uh, to be honest, it could. I mean, I'd expect this to be in a calculator test.
Yeah.
If it did come up in a non-calculator test, I'd imagine that the calculations shouldn't be too hard or too taxing, but working them out would then take you too long. I don't think anything like that should happen.
Okay.
Yeah. Here is the next one.
Um, could the answer be um 7,500?
Let's see. So So it's number 4, yeah? Let's look at the different, let's analyze it. Ola picks a 5-digit odd number. The second digit is a third of the first digit. The third digit is less than 6. How many different numbers could she pick? So it's 5 digits. How many different numbers could she pick? Sorry. So we've got 1, 2, 3, 4, and 5. Oh, I got so big at the end. So, okay, let's ask the first question. How many numbers could go in the first position?
Could it be 10?
Yeah. Well, if it's a 5-digit odd number, if the number actually is 5 digits, then it wouldn't make sense to start it with a 0.
Oh, okay.
So in that case, it's going to be 1 to 9, not 0 to 9. So we've only got options. What about the second?
Could it be 3?
And why do you say that?
Because it said it will be a third of the first digit. So if it was gonna be a whole number, it'll be 3. There'll be
Yeah,
3 numbers.
but in that case, I just realized we both made a mistake. That means the first digit only has 3 options too. Because if the
Oh,
second digit is a third of the first digit, that means the first digit must be divisible by 3. Otherwise, it wouldn't work.
okay.
So we can have 3, 6, or 9 in the first digit. So that's 3 options. And then as a result of that, yes, the second is also going to have 3 digits because it's going to be either 1, 2, or 3. And then the next.
5.
Yep, because you've got 0, 1, 2, 3. Actually, no, you've got more than 5. If the third digit is less than 6, you've got 5, 4, 3, 2, 1, and 0.
Oh, yeah.
Yep. So I guess one thing to think about is where you can use 0 and where you can't use 0. And the fourth one,
Um, 10, I think.
yeah, that one can be 10, yeah. And the fifth one,
5.
why 5?
Because it's odd. The number is odd.
Yes, it's odd, so it's got to end in 1, 3, 5, 7, or 9. So there we go. So we've got those numbers and we multiply those together. So 5 times 10 is 300 times 9 is 2,700. Ready for the next?
Yeah.
Oh,
I'm not sure about this one.
not sure about this one. Okay, so Jackson makes 5-digit numbers using all of these cards. How many different numbers greater than 50,000 can he make? Okay, so similar thing to before. We're still going to have constraints. So I guess the first question is, how many different numbers or digits can go in the first box?
3.
Why is that?
Because 4 and 3 are less than 5, so any number that you make will be less than 50,000.
Perfect. So, yep, we've got 3 different options to go here. So we can either put 5 or 9 or 8. And then how many can go in the second option?
Oh, would it be 5?
Why is that?
Because there's 5 numbers there.
But he's making the 5-digit numbers using all of these cards.
Oh, 4.
So yeah, he's only got 4 left. And then for the next one,
3.
Yep. Next one.
2.
Yep. And all those superfluous. The next one.
1.
Yep. Good. So we just multiply this together. And that looks like it's going to be 72. Do you want to keep working on this, or is there something else you want to work on? I mean, we don't have a lot of time left, but
Um, can we keep working on this?
you want to keep working on this? Okay, cool. Here's the next question.
Would the answer be 1,247?
Let's see. Let's go through it. So, righty ho. So what did we do?
I did 9 times 8,
Mm-hmm.
9 times 15, and 9 times 8 times 15. Then I added it together.
Okay. So if Max is going to attend either a Monday class, and a Wednesday class, so we've got Monday and Wednesday, so 9 times 8. Yep. If we've got a Monday class or a Friday class, 9 times 15. Monday, Wednesday, Friday, that's 9 times 8 times 15. That you did, yeah? Good.
Oh yeah.
Nice. 9 times 8 plus 9 times 15 plus 9 times 8 times 15. Okay. And what answer did you get for that, sorry?
Oh, 1,247.
Say that again, sorry.
1,247.
1,247.
Yeah.
I've got a different answer in my calculator. Yeah, I'm getting a different answer in my calculator.
Oh.
On my calculator, I'm getting 1,287. Might be worth trying again.
Oh, it's because of the way I didn't multiply the 9 times 8 times 15, right?
Oh, okay. Well, there we go. I think we have time for one more. What's that? Okay, yeah, we've got time for one more. Just this one here.
Um, I got 60,480.
Let's go through how you did it. So, James is creating a 6-digit code to lock his iPad. He does not repeat any digits. How many possible codes can James create?
Since it said it did not repeat any digit, I just did. Oh wait, but since would you do like the 10? Oh wait, sorry, I think I did it wrong.
Okay. Do you want some more time to think about it?
Oh yeah.
Good.
Oh, never mind. I think it's okay.
Okay. So tell me what you did.
I did 9 times 8 times 7 times 6 times 5 times 4.
So okay. Well, so how many options can go in the first one?
9.
Okay. This is where it's a 6-digit code, but if you think about a code can start with a 0 if you've got like any sort of phone and you've got a code. If someone asks you for a pin or whatever, you can start it with a 0. So in actual fact, the
Oh,
first one is going to be 10.
oh yeah.
I know it's a bit tricky to decipher when can you start with a 0, when can you not start with a 0, but because this is a code, to be honest, an actual exam question would always make it clear whether you can or can't start with a 0. There will always be something that makes it clear. But because these are just sort of practice, um, it's for us to think it, it's up to us to think about it. Okay. So there are 10 possibilities in the first option. And then in the next one,
9.
so you've got 9, and then the next one.
8.
Yep. And then the next one.
7.
Yep.
7. 6.
And then the next one. Yep. Then in the next one.
5.
Yep. So it's 10 times 9 times 8 times 7 times 6 times 5.
Wait. 151,200.
You say 151,200.
Yeah.
Okay, let's just check that. Okay, sorry. Just checking the calculator. Yep, that's good. Next, we've got this last question, and we'll be done for the day.
I'm not sure about what to do.
So again, it's the same thing where we just count how many possibilities can we have for the first, second, third, fourth, fifth, and sixth digits.
Um,
Mm.
so would it still be, would it be 9 for the first?
Say that one more time.
Would it be 9 for the first box?
Well, we got to read. So it says the first 2 digits of his code, he uses a multiple of 13. So if that's the case, then yeah, if it's the case that he uses the first 2 digits to be a multiple of 13, how many multiples of 13 are there?
Oh, would it 2?
Well, what multiples of 13 did you have?
Wait, can I think about the question again? Wait, for the first bit, how many numbers would they expect you to go up to?
Well, how many possible multiples of 13 could fit in the first two boxes?
Oh, oh, or would that be 7?
Okay, so this is where it's a bit of contention. So yes and no. So you've got the numbers 13, 26, 39, 52, 65, 78, and 91. But because it's a 6-digit code still for this iPad or whatever, and you are allowed to start off digits with zeros, technically
Oh,
you,
8.
pardon?
8.
Yeah, it's going to be 8 because you could also have 00, which is 0, which technically is a multiple of 13 because 13 times 0 gives you 0. Again, not the typical kind of thing you'd get in an exam. They'd always make it clear, but that's just one thing that I thought I'd add. Okay, the third digit is 1 greater than the fourth digit. So we've got the already in the first two, you've got 8. And there's 3, 4, 5, 6. So the third digit is 1 greater than the fourth digit. So how many possibilities can we have?
Oh, I forgot how it was. If 1 is greater, I forgot how we're supposed to do that.
Well, we just have to ask ourselves how many possibilities are there. So the third digit is 1 greater than the fourth. So how many possibilities can we put in the third if it's got to be 1 greater?
10.
Well, if we put if we were able to put 10 different ones, then unfortunately, if you had 0, 0 isn't greater than any other digit.
Oh, yeah, 9.
So technically you can put 9, and then yeah, it's thinking about how many you can then put in the next digit. So, and it's specifically it has to be 1 greater. So this one's actually a bit easier because we only know it, we know it's got to be 1 greater. So we've got 9 options that go in the second,
8.
which are going to be 1 to 9. But then that determines what the fourth digit has to be. The fourth digit is also going to be 9 options because you've got the digit afterwards has to be 1 less. So if the numbers in the third digit are going to be 1 to 9, then the ones in the fourth digit are going to be 0 to 8, respectively. And the next?
Oh, okay. Um, could there be 40? Wait, wait. Could it be? Oh, 1 second, please.
Okay. I just realized as well for this one, there's only 9 possibilities altogether because for the 9 numbers that there are, for each of those, there's only 1 possibility for the next. So it makes it 9 altogether, or 9 times 1.
Could it be 35?
For which one?
The last bit?
Well, for the last two digits, uses an odd number between 10 and 80.
Yeah.
Okay, so how did you get that?
Because 10 and 8, between 10 and 80, there's 70 numbers. So I just halved it.
Well, uh, yeah, more or less, you can do that. Technically, between 10 and 80, it's 71 numbers, but yeah, if you're disregarding either the 10 or the 80, then you're left with 70 numbers, and then half of them are even, half of them are odd. So, yep, you can do that.
Wait, how there 71?
Because if you go from 10, if you count the number 10 and 80 as well, then that would make 71 numbers. It's like me asking you how many numbers are there from 1 to 9. You don't just do 9 take away 1.
Oh, okay.
Yeah. So
Yeah.
because you're including the two numbers as well. Okay, so yeah, that works. So yep, that works. And then yeah, now we can just multiply these numbers together. So 8 by 9 by 35, and then we are good. All good?
Yeah.
Great. So let's just work out the answer to this and then we're done. So that is 2520. So there we go.